Let's see if you can answer any of these questions in this Do Now activity. Can you identify all possible radii? Radii is a term that's plural for radius, and as you can see in this circle, we have more than one radius. Let's identify them. The most obvious one I think you can see is OC. The second one is OB, and the third one is AO. Hopefully you were able to determine that the diameter is AB, that's double the radius. And we're going to name a pair of angles. I see an obtuse one, angle AOC, and I also see angle COB. And the name of this circle is called circle O. We go by the center of the circle. This lesson involves the geometry of circles. So some of the objectives that we will definitely address is that we will define and identify basic parts of a circle in order to solve geometric circle problems. We will solve for angle measures and segment measures. We will find arc measures based on properties and theorems. And finally, we will effectively use definitions and theorems to solve circle problems. So the definition of a circle is that it is a set of all points on a plane equidistant from a fixed point. The fixed point is called the center of the circle. A segment whose endpoints are the center and a point contained on the circle is the radius. And blank of the same circle are congruent radii. Parts, terms, and definitions. A full circle is equal to 360 degrees. A semicircle is equal to 180 degrees. In terms of arcs, we talk about major and minor arcs. A major arc is greater than 180 degrees. So I'm going to outline a major arc in this circle, and if we go around here, we label it as arc AB, and that's major arc greater than 180 degrees. On the other hand, a minor arc is less than 180 degrees, and that's this inside region right here of this little piece of pie. So that's a minor arc, and we also label it as AB. So we just use the term major arc or minor arc to distinguish for the arc AB. Now we have something called chords, and that is a line segment whose endpoints are points on the circle. So we can just draw a line anywhere in the circle, and we call them chords, as long as the two endpoints are on the circle. We also have a chord that's special. That contains the center of the circle. And if we have a chord that contains the center of the circle, we call that the diameter, which is double the radius. And diameters of the same circle are all equal or have equal length. A line that intersects the circle at only one point is tangent. So as you can see, we have this line that's outside, and it touches the circle in one point right here, and we call that the point of tangency. So this is a tangent line. Then we have something called the secant, and that's a line segment that has one endpoint on the circle, intersects the circle at another point, as well as in between the endpoints where the opposite endpoint is outside the circle. Basically, if you look at the circle that I have here, if you compare that to an eyeball, so it kind of looks spherical like an eyeball with a little undilated pupil inside, we're going to draw a line through it. And instead of drawing it, I'm going to try to put it in there. If you could picture a hairpin, going through it, and I'm drawing two secant lines now. If I could just have this come out a little bit more. There we go. Okay, it's basically taking a hairpin and just shoving it through an eyeball. I know that's kind of gory to think about, but it's effective, and it's totally visual for you to see that. So the secant is a line. So it's a line segment that extends from the external part of the circle and goes right through the circle. And again, I have two secants drawn here. We have 5 angle theorems that we need to discuss. The first one is central angles. It has its vertex at the center of the circle, and the angle sides consist of the radii. So angle AOB is called a central angle, and it intercepts arc AB. The central angle is equal in measure to the intercepted arc. So that's a theorem or property. So here's our central angle. As you can see, we have an angle measure of 60 degrees. That is the value of the measure of the arc. So the measure of angle AOB is equal to 60. Therefore, the measure of arc AB is equal to 60. Central angles. Congruent central angles have congruent arcs. So as you can see, we have this hourglass, and it kind of looks like vertical angles here. So we are going to call them vertical angles, but they're also known as central angles. So these two arcs are congruent because the central angles are congruent. So each measure 40 degrees here, so do the arcs. In the same circle, congruent central angles have congruent arcs, and congruent arcs have congruent angles. So I can tell you that CD also has an arc measure of 60 degrees, along with AB, and along with central angles AOB and DOC. So arc AB is congruent to arc CD. So let's practice some of these. We would like to find x. You're given that AD is the diameter, and the measure of angle AOB is 78 degrees. I'm going to put that into my diagram. That is my central angle, and the measure of angle DOC is 40 degrees. So in order to find x, we need to find its central angle because they have equal values. And we are told that we have a diameter here, so that's AOD. And it's a line, and we know that adjacent angles on a line is equal to 180 degrees. So if I find the sum of 78 and 40, we get a difference of 62. And as a result of that, this central angle is equal to the arc that it intercepts, so BC, or arc BC, is the same thing as x, which is equal to 62 degrees, which is what we were looking for. In this case, we need to find WX and Y, as well as the measure of arc ABC. So that line is not supposed to be there. It's just the way that it registered when I put my PowerPoint into this medium. So we're looking for the measure of arc ABC. Line AC is a diameter, so just from them telling us that any angle that's adjacent on that line is going to have a sum of 180 degrees. So the measure of arc AD is 60 degrees, which I can see is labeled in the diagram, and the measure of angle BOC is 70 degrees, which is the central angle, which is also labeled. I have this line here, AOC, as my diameter, so that means the sum of x and 70 is equal to 180. So 180 take away 70 is 110 degrees. So that's x. Y we can see here is 60 degrees because the central angle is the same as the arc AD. And the measure of this arc, its sum is equal to 180 degrees because of the diameter AOC, and I already know 60 degrees is arc AD, so I subtract that from 180, and I get 120 degrees for angle Z, because arc DC is 120, and that's the same degree measure as central angle Z. And the measure of arc ABC is 110 plus 70, so it's 180 degrees. Okay, so I have KL is the diameter, and we need to find arc LM as well as arc KN. So since we have diameter KL, I can see that the sum of these two angles here are equal to 180, so I'm going to write that out. And I'm going to solve for x. So x is equal to 54. I'm going to substitute in. Angle KCM is equal to 138 degrees, which makes its arc KM equal to 138 degrees. 54 minus 12 is equal to 42 degrees. So the measure of angle LCM is 42, which makes arc LM 42 degrees. 2 times 54 plus 10 is the measure of angle NCL. So that makes this equal to 118 degrees. So arc NL is 118. And then I'm going to find the sum of all three arcs here. Subtract it from 360 degrees, which is the measure of the entire circle, and I'll have KN left. So arc LM is 42, and I have to find KN by subtracting the sum of all the other arcs from 360. And that's 62 degrees. You are now responsible for the associated work that goes with this lesson, and you will complete that in class.